Hi, my name is Kristen. I'm the author of the book 5 Lines of Code, and you're listening to the Agile Uprising podcast.
Greetings and welcome to another edition of the Agile Uprising podcast. I'm your host, Jay Hrcsko. Joined with me, I have fellow friend and board member Brad Stokes.
Hey.
And Discord coalition member, general contributor to the insanity that is our Discord server, Frans Alkemade. Frans, good morning.
Go. Morning, Jay.
And this episode, we're going to be interviewing Christian Clausen. Christian is the author of the book 5 Lines of Code, which surprisingly for a non-developer, the only non-developer on this conversation, I actually got 90% of it. So Christian, it is a testament to your ability to write. So Christian, thank you for joining us.
Thank you for having me. And thanks for the kind words.
No problem. The pleasure is all ours. So first, let's start off with giving our listeners a little bit about you. So if you go into a little bit about your background, and then we'll transition to more about like the book and how it came about.
Okay. So I started coding when I was very young, and I thought it was super fun because I could start solving problems and building stuff with my own hands. And I felt like, I think I felt powerful in front of a computer. So I always did a lot of coding. And then I started university thinking it was going to be a breeze. It wasn't. It was very tough. And by the end of it, I got so intrigued by staying in academia that I studied a lot of type theory and advanced programming language theory, aiming to get a PhD. But when the time came after spending a long time in university, I decided to go into the industry and become a consultant instead. And that's when I saw a lot of potential for people to learn more about refactoring and code quality and stuff. And I figured they were smart people, so it wasn't that they couldn't learn it. It was probably just that it was too much effort to get started with. And so that's also why I started writing the book.
Oh, you gave me the perfect lead in right there. So your book is 5 Lines of Code, and you specifically deal with the idea of refactoring. And again, as a non-developer, I thought it was pretty easy to get to, pretty interesting. I mean, if I understood the syntax about how to write the language, I probably could have taken it and ran with it. But even in the introduction alone, you make a couple of good observations that even if someone who's listening to this podcast is not a developer or not a DevOps guy, you can still understand the necessity for refactoring your code. For example, the first note of yours that I caught was, the quote was, "The way refactoring is usually taught with code smells and unit testing imposes an unnecessarily high barrier to entry." And I think that's a very astute observation, because even as an agile coaching guy, right, when someone says we're going to do test-driven development with paired programming, before I was fully bought into the agile piece, the project manager mind is going, wait, what? You're gonna slow down and write tests first? Like it was completely incongruent. So, and I think, Christian, that ties to the experience you just said, where you started getting into the code and then realizing, well, it wasn't very difficult, but then the teaching part of it gets very, very dense.
Well, I mean, the language itself can actually scare people away. How about we actually just start off, what is refactoring? A few programmers in the room, but I think, it's one of those things that people hear about and they go, oh, that sounds really dangerous. What's refactoring? Let's just go there.
Refactoring, just on the face of it, is just changing code without changing the functionality or the external behavior, as we like to say. And there are some different ways to interpret that. Interpret that. That's the word I'm looking for. Different ways of interpreting that. Some or most people associated with improving the structure of the code, including Martin Fowler and myself also, it's about making the code more readable and more maintainable. That's specifically the type of refactoring that we're looking at, although refactoring could just be any change that doesn't affect the functionality. We also do allow typically that the performance is affected, even though that's an external behavior that's observable. But that's because typically that is not the most expensive thing in the code. Is not maintaining a constant high performance, but more that the code is easy to work with and easy to extend.
And you had a one-liner that tied to that, which I thought was really brilliant, where you said, if we deliver unrefactored code, we are only borrowing time from the next programmer. And in my non-technical roles as a PM, as an agile guy, we always came across certain applications where you'd bring them up and say, Christian, we got to make a change to XYZ. And you see Christian visibly just go, ugh, because they knew they were going to spend way more time trying to understand what was going on behind the scenes as opposed to actually making the change that they need to make. So there's something to be said about the simplicity that goes with refactoring. So let me ask you, how'd you end up with 5 lines? Why not 4 or 3 or even 7?
So the rule of 5 lines of code is, of course, so it gave the name to the book, obviously. It's the first rule that's presented in the book, and it's because the context of the book is a 2D game. And in a 2D game, the fundamental data structure, excuse me, the fundamental data structure is a 2D array, right? Because it corresponds to the tiles on the screen. And to run through and do a linear pass over that fundamental data structure, it takes exactly 5 lines of code. And as it says in the book, if you're working with something that has 26 dimensions, 5 lines is not going to cut it for you. So you should probably do 27 lines of code or something more around that space, right? And so it depends on what context you're currently in. And that also means not every function in a program needs to have the same limit, because you may change the fundamental data structure from time to time. It's just that in the book and in general, in most cases, 5 lines are sufficient. I've learned since I came up with the rule actually that there is some research to suggest that 5 or 6 lines is the sweet spot where the number of errors per line is actually lowest.
Wow.
That's
a motivator.
Yeah.
That is an interesting thought, because I mean, I've definitely been able to inherit some applications that had rather large main functions and such. So the idea of being able to find a sweet spot closer to the 5 or 6, it's definitely an interesting observation.
I mean, and I know from my just observing my software engineers I've worked with, friends and stuff, they spend more time just standing there staring at the screen, or sitting there, I should say, staring at the screen, trying to figure out what am I looking at, than to actually make the change. So if you go in with that elegance, it probably makes everybody's life easier all the way around.
Yeah, there's also like a really interesting observation that someone made at a conference. I can't remember who right now. But the fact is that we usually do estimates based on, this task feels like this task in complexity. And so we give some estimate based on that. But the problem is that the biggest expense when implementing something is not the task itself. It's actually the environment where the task needs to be implemented. So it's all of these couplings that you need to deal with to implement it. So in order to improve predictability and improve your estimates, you actually need to do refactoring so that your code base is at least consistent throughout.
Yeah, the 5 lines, it almost lends itself to a functional programming space. That idea, one in, one out, and you always know what's coming back out of the function. Is that some of the inspiration that you took for that, or is it just felt like the right? Yeah,
that's a very intelligent observation. A lot of the things in the book actually strive to sort of simulate at least some of the functional behavior that we want. Like there's a lot, chapter 6 concerns itself mostly with encapsulation. And that's also to do with the fact that we want to tie functionality to the data that it works over and not to all sorts of other data that it can somehow get access to. So if we enforce strict encapsulation, we get actually the same effect as in a functional language where you have usually libraries that don't concern themselves with what's in a list, just that it is a list, right? And so that thing sort of forces everything to go nicely together and gain some of the same advantages we get from functional programming. And I am a functional programmer at heart. I've both done functional programming in industry and a lot at university and also in research.
Yep.
So I'm going to ask it might be an obvious question, but things like refactoring, even things like XP practices, if you go for a computer engineering degree or computer science degree in undergrad, do they teach these things? Or is it like one of those things where it's a bullet in a course that, oh yeah, and you should refactor moving along? Because I mean, my experience is when you get into academia, sometimes you get a lot of professors who are, 20 years, 10 years removed from what's actually going on. Yeah. So, I mean, I've done speaking engagements where I'll show up at a college university and they're still teaching like waterfall, project management, agile is like a 2-bullet afterthought. So is this something, Christian, that's typically taught?
I can only speak to my own experience, of course, here. So as a student myself, we were taught refactoring was mostly mentioned as an afterthought, as you said, as part of the red-green refactor test-driven development loop. And test-driven development was really the focus of that course, which I think is reasonable because I also happen to think that test-driven development is a lot more difficult than refactoring is. That's also the point of the book that you brought up. Like, refactoring doesn't need to be hard, actually. TDD, though, can be a bit mind-bending at first, at least.
Yes.
TDD is awesome. And I find guys coming out of uni, actually, one of the things I've found in industry is guys coming out of uni, that you talk to them about TDD and they look at you blankly. Yeah. What's that? Yeah. I have no idea.
And also you hit like these issues with how do you test something that has a lot of graphics capabilities, or like how do you test stuff that is tightly coupled to timing or scheduling or embedded software, and all these sort of external things get really hard, right? Because you can't just sit down and do simulators forever. And TDD can get arbitrarily complicated, I think.
Yes.
Whereas refactoring stays pretty much the same, actually. Mostly it's about the idea of having code be a movable entity, something that you can think and work with abstractly. Regarding...
sorry, I was actually just thinking about this, though. TDD, having your unit tests and bits and pieces in place, refactoring without is clearly possible, but how do you know you haven't broken something?
Yeah, that's a great question. It's also one that has been raised by a lot of people reading my book, because I say that we're going to do the book's content without doing any testing. I do like to do testing in the real world when I work with systems. The more I don't know them intimately and the more coupled they are, the more important testing is, because the more likely it is that you change something over here and it's going to do something in a completely different space, right? And that's where testing can be super powerful. I do prefer, though, and that's probably also some of my functional background shining through, if the types can give me those validations instead. Because type systems can actually be extraordinarily powerful when wielded correctly. Unfortunately, that's also difficult to learn. So it's not like it's just something that you can do easily. But I try to, I came up with, I think, a pattern called enforced sequence in the book that actually moves an invariant from the control flow into the type system, which means that without being a functional programmer or knowing any type theory, you can start using that already right now. And I really want to make concepts like that accessible as much as I can.
Well, you had a few other patterns in the book that I noticed stuck out to me, like the enum function, the enum sort of things where you've just got a list that can't be repeated, etc., just to help enforce those sort of non-mutability. So thinking about it, I know you mentioned in the book microservices were definitely part of your philosophy there. It's would seem that to get into refactoring, like if you're refactoring something that's big, bloated, old, super tightly coupled, you're in for a hard time. Is that a fair enough statement?
Well, you're in for a long run, at least. Long run.
Maybe not hard time, but long run. And I like the chuckles in the background. Thank you. So, I mean, if you're just starting it, is it best to pick something that you can see could benefit from some refactoring a little bit and just start biting off chunks, or do you get your arms dirty? How do you suggest that somebody sitting out there in listener land is going, yeah, that's great, but I have this monolithic, tightly coupled web application that is 6,000 lines long for just this function alone. And we might laugh, but God, they're out there.
Yeah, they are out there. I think the best thing to do first, I think you need to actually just learn refactoring, get used to it before you start taking the challenging parts and decomposing it like a monolith completely. So I think just starting by doing anything really and thinking about refactoring, making it part of your everyday work, that is the best step to start with. And that could be through just following these rules pretty blindly. As I recommend people who are completely inexperienced with refactoring, just do what the name says, right? Just follow that. That's easier to remember. And then as you evolve, sort of switch to the descriptions, take 6 lines of code sometimes, or 12 lines for things where that's appropriate. And then finally just transition to smells, because at some point your eyes get used to seeing how you like your functions to be. And then you can sort of determine yourself when it's a problem and when it's not a problem. And that's much stronger. And you can do that either by doing like, what are they called? Katas in dojos, like where you practice together as a team, or you can do it directly on production code if you have the confidence to do that and test cases and whatever.
So then you're willing to say that while at the start, when someone starts picking up the refactoring methods that you're talking about, they should definitely be focusing on following the rules, and code smells are a bit more intricate. But as they can move forward and they have spent more time, it's okay to somewhat push away from the rules you set and move more to the traditional methodology of code smells.
Yeah, definitely.
Okay.
Yeah, I didn't intend them to be, this is how perfect code should be forever and that's it. Because then you could just take the rules, put them into like some software and then publish that software. We'd never need to have humans do anything ever again. But a lot of what's in the book has the basic philosophy that the greatest computer we have is in our head already. So remove some of the complexity, like use that computer to reduce some of the complexity that's accidentally put there through time pressure or ignorance or whatever.
Yeah. So if you're looking at your rules or your heuristics that you've set throughout the book, somebody's coming at this fresh, 5 lines of code, really easy to get, really easy to grok. But then we look at something like don't use else if, don't use else ifs, use or if else's, use if else if. What are some of the other ones there that you would consider very important, fundamental to getting your brain ticking towards the right?
I think my favorite pattern in the book is actually already in chapter 4, where we replace type code with classes and then proceed to push code into those classes, because it takes something that's a very static structure and that's spread out across the whole application potentially, with the enums being switched on everywhere. There's no direct coupling to actually the data that they encompass. And then you put it into classes instead, and suddenly everything that is related to that value is together, and you can see the invariance inside of that class instead of spread out across the whole application. That the first time I realized that, it was mind-blowing. I thought it was amazing. And taking something that is, what do I call it? Like static control flow, and making it a dynamic thing, like objects that you can pass around, is just so powerful. And it gives the same thing as when you pass a function, a high order function in a functional language, right? That's the same sort of decoupling that you get. That's just super cool. So I think chapter 4, that's when, that's the real kicker.
I just love that now we've hit a point where object orientation is just in everything, that we can just say, oh no, just make it a class. Like I started with PHP, man. We only recently got the big kid tools of classes. I think it was great.
Yeah, I did too. It's not my favorite language.
That was put very gently.
It is a popular joke in development that how bad PHP is, that I think it speaks very loudly for how much of a pain in the butt it's been historically to work with.
Yeah. Yeah, and
yes, but it has such low barriers of entry. So
yes, I like the low barriers of entry.
One of the other things you call out, Christian, in the book, where you talk about code readability, right? And again, I'm coming from the non-software developer lens, and where you said that you make the remark that, regardless of syntax, if the code is written cleanly and refactored properly, you can pretty much pick it up and look at it in almost like a plain language. And as I was walking, I didn't do any of the exercises. I'll admit, shame on me. I didn't do any of the exercises. But as I was reading through the code examples and I got further in the book, I was thinking to myself, this, even for someone like me who doesn't ever write a line of code, I can pick it up and looking at code that's written like that, I can pretty much get, like you said, Brad, I can grok it and get the gist of what you're trying to do. I mean, Brad made a joke about these large, monolithic, highly coupled web applications. In a previous life of mine, I sat next to an ETL developer who maintained the payroll ETL job for, I don't know if I should name the company. It is a large internet provider in the United States. And his running joke was he inherited this thing, and it was thousands of lines, thousands and thousands of lines of how this job runs. And he said the only code comment was, and then the magic happens. And then it was the entire chunk of code. So he said the first time he opened it up, he looked at it and he just actually closed it, went and got a cup of coffee. He said, I don't know if I'm ready for this. So there is something to be said for that plain language translation for, especially, I mean, for those of us that are listening, we have a lot of listeners who are Agile coaches, right? For everyone out there who's not necessarily, in an IDE building applications, there's something to be said about having the ability to look at something and at least come up with that. There's less translation if I'm talking to you and I'm using the code as a reference that I can actually understand.
There's a lot of argument for still reading good old Uncle Bob.
I came across one of his lectures. He was screaming at people, and I just kind of giggled. He reminds me of some of the best teachers I've had where they just tip over and start yelling. Franz, you've been quiet, but I know you had a whole bunch of questions. I think it's because it's 6 a.m. my time.
Yeah. Well, I don't want to stop over the conversation. So I very much enjoyed reading your book. I know you and I had a little bit of a talk before the session started. One of the things I really enjoy is that you have put a lot of work into making this very approachable for a junior audience. So someone who's just starting up, they're not the person that would traditionally be doing your refactoring, the person who's been on the job for 20 years. If you had to make a sales pitch to a senior engineer to pick this up and go through it, what would your 10-second pitch be?
For the book?
Yeah.
I would say that it's probably a good way to help their juniors get started. That's what I used it for. I used to do a lot of upskilling of the new people we hired when I was a consultant at another place, and I would have a lot of trouble sort of arguing with the other tech leads about what is good code, how do we want this to look and feel, and how does it tie in with these systems that we're building. And then I would get these new, completely what do we call them?
Green.
Young and inexperienced. Green. Like they had no conception of what good code was. And they just wanted to do stuff. And if I told them something, they were going to do that thing. So I started thinking about how can I actually tell them something that's super simple and applicable so as to not kill their spirits, but also like make them go on the right direction. Right. And I started doing some of these rules back then, and then they've gone through multiple iterations as with everything in tech. They've gotten pretty good, I think.
Yeah. Well, I've absolutely adored the book. And I've definitely pushed 2 or 3 of my guys who are a bit younger to look through it because we talked briefly on some of the issues we run into with people when they come out of college, not necessarily having the most practical understanding of what we're doing right now. And I think taking something that's as monolithic as refactoring and saying you don't need to start with TDD, you don't need to start with this huge automated DevOps stack. You can just come in there and here's a simple set of rules of how to read your code or read someone else's code, because realistically, if you're refactoring, it's not necessarily yours.
Yeah.
And make it into something that everybody else can read better. I very much enjoyed that. Let's say
so much actually that I go and we have a service at my current work where I go to teams and they open up their application that I've never seen before, and we refactor it live in a mob programming session. So I kick off the ball by giving them some of the rules. Usually we start with chapter 3, where the first rules are. And then we just start decomposing these completely strange to me applications. Of course, with a lot of tool support, because then it's safer. But yeah.
So that's something I did want to broach on. One of the things that I kind of want to lead into where a developer would go next after your book. You talk about the introduction of TDD, the introduction of automated testing. If I'm a mid-level junior person, I have some experience with refactoring. I've read your book. I'm now a little bit better at it. Where do they go next? What is there a particular path you would recommend as a senior engineer?
I think I recommend people take slightly different paths after that point, because there are so many diverse things needed in a team. So automated testing is definitely worth having someone be really excellent at in your team, and then having everybody else be at least decent level. But I say the same thing about Git, for instance. It's really nice to have a master Git person on your team to just fix it when you accidentally delete something from master and then force push. You know, it happens. and there's
I've never seen that happen on a team. I don't know what you're talking about. I would never do that.
Exactly. And there are also so many things about just team dynamics and how to develop software and DevOps practices and all of these things. I recommend people have a basic knowledge of most of them and then have one expert in each of them or something like that. Try to balance the skills out.
Okay. I do think it was very bold for, what was it, your first chapter of the actual coding section? You went into how people should start learning how to properly utilize the compiler. I was like, oh, wow, you usually avoid that when you're talking to someone who's a bit newer. I enjoy this conversation.
The
compilers are
nice. I love it.
they're big monolithic spooky black boxes. You put your code in there and then you get something the machine can read.
And then you're frustrated.
Let me see.
Well, I have a question while you're thinking, Frans. So, Christian, taking a step back, judging by the experiences that you've told us, like you've taken your battle scars. I'm assuming you've been around the block a few times. I'm running out of analogies. At what point did you just say, I got to write a book? Like, I know I got something here. What was that tipping point that led you to say, you know what, I'm going to slow down and actually put hands to paper because I know it's not fast and it's not easy. So it's completely outside your normal purview of writing code and consulting engineering practices. Where did that come from?
So I've always loved teaching. When I was at university, I took as many teaching assistant positions as I could get. And at some point, there were no spots for me to take. And I got a little sad. And I wanted to teach more. I felt like I had more to give. So what I did was I found some of the people I'd taught already and asked them if they'd be interested in joining me in some Friday talks. They could talk, I could talk, just sharing whatever practical thing you've been working on in your spare time, right? Was the idea of it. And I made an open invitation to anyone at the university. As it turns out, computer scientists are pretty timid. And so I ended up having to actually host the first 60 weeks on my own. But then it started taking off and people started coming and sharing their experiences and growing this community that I'd started. And it actually continued after I stopped university. Then about a year after or something, I was talking with my best friend, who's also a computer scientist. And he used to come to these sessions and he used to think they were mind-blowing, at least some of them, right? And so he said, Christian, can you improvise a talk like that? And I'm like, I don't know. He's like, show me something, impress me, right? And I'm like, okay, we opened up an editor because the only thing I can do improvisingly is code. And so I opened up an editor and we coded out pretty much the exact starting point of the book in one go that Saturday. And then that didn't take that long. So he had more time. And I was like, that wasn't the impressive part. It was not the game. It's what we're going to do next, right? And he agreed that it already, like my book actually skipped some of the most important things to learn about software, or the first things to learn about how to make software better, like try and keep it simple and stuff. I don't go into that at all. I just assume that people have been doing some of that at least during their learning. And then he agreed that that was pretty typical quality for what he would see in his workplace. And then we started refactoring it. And I knew that he was the type of person that I'm writing for. He was busy. He didn't want to get like a PhD dissertation about how refactoring ties together. And like Martin Fowler's book, I love it. It's a masterpiece. It blew my mind, but it has so much content that it can be overwhelming. So I couldn't just start with smells. I couldn't just start with all the refactoring. So I had to think of something new. And I came up with the rules. And a lot of the rules had some early form during that one session. And on my way home, I was like, this was actually really cool. Maybe I should write it down so I don't forget it. And I wrote it down when I got home. And then I put it on a shelf, as you do. And a year after I took it out, I read it. I was like, oh, that's really smart. That's actually a super good idea. And I was surprising myself with some of these little details that I had somehow noticed. And then I noticed more details and I put them down. And then another year passed with it on the shelf. Then I took it down and one of my mentors had the brilliant observation, what good is it doing anything on your hard drive? And so
That's-
he encouraged me to contact a publisher. And then,
Right.
and then the grind started.
It's funny how you wrote it, put it away, prayed back to it, and said, "Wow, I really knew what I was talking about at this moment. I should do something with it."
One of my greatest fears is actually talking to someone someday who expects me to know all of the things in the book in real life. And it's like, I've picked it up over 3 years, right? It's the best ideas I've had for 3 years. So it's not something that I do every single day.
Well, I thank you, Christian, for that honest confession, because some of the authors we have interviewed, I guarantee you have the same fear, but have never voiced it. So I give you a lot of credit for being able to say that. Hey, if somebody comes up and wants to ask about page 274, this might be a little bit of an interesting conversation, because I'd be like, isn't that the appendix?
Yeah.
Brad, Frans, any other questions?
So I know we have all of our various rules that we go through in taking what you have, taking what you've learned. If I needed to focus on 2 or 3 that you have found in your experience are the most effective at readability, so making it so your code goes, or not even necessarily readability, makes it so code is easier to maintain, what 3 would you recommend somebody start on or focus on in the beginning?
So I used to say, and this is probably the hallmark of someone who has a deep understanding of something, almost all of the patterns and almost all of the refactorings in my book have the same goal. They're all going towards some variation of strategy pattern, which is to say late binding in some way. And it's also the same with higher order functions. They're also just strategy patterns, right? Okay. So that is the thing that you need to take away from it. If you take just one structural thing, everything can be reduced to sort of that thing. Then it's important with encapsulation. It's important with small functions and stuff. And good naming is cool, but strategy pattern is the architecture cornerstone.
Okay, I know I'm personally a big sucker for meaningful variable names and function names. I think we can all agree there's nothing more irritating than you pick up a big piece of code and everything is just function A, function B. It's like, I have no problem spending 45 minutes reading through everything that somebody wrote and trying to figure out what it does.
Yeah, I think the only thing worse is a merge conflict because somebody used tabs as opposed to spaces.
Yeah, or it didn't integrate within 6 months.
That one too. That one's awesome. Look, obviously with the refactor, there's certain other practices that, are more and more commonplace, but I still see them sadly lacking, like using a thing like Prettier, for instance. So you're actually enforcing code standards within your organization, within your teams. Do you actually advocate for that? Well, I'm guessing that you advocate for something like that. Is that like one of the fundamentals? I mean, one of the things that you hear about agility is one of the core foundations of agility, and people forget it's even the principles is strong technical foundation. Is things like using linters, are there tools that you recommend that people use that actually help them get to the point where their refactoring isn't going to just, as said, cause a conflict because you've got uppercase in the wrong place, or you don't have any code analysis?
Yeah, so there's a lot of interesting things in the question that you're asking. So first of all, when I started writing the book and talked with Manning, I had to make the decision whether this book was going to focus on the individuals or the teams, because in all of my work, I advocate that the team is the only method of delivery, right? You should not put responsibilities on people, you should put them on teams. And there are so many reasons for that, and great research done on that also. Why did I write my book on the personal level, right? Because I think that when I'm training and when it's a personal experience, I still do a lot of trainings and teaching and stuff, and I have to I have to understand where the person is and move the person, because I can't move the team in that sense. And that's why I don't really tackle many of those. I mention a lot of things that make sense in teams and in actual industry, but using linters and avoiding merge conflicts is mostly a team issue, actually. And there is no way to avoid some sort of merge conflict if you work in parallel. Like, short of doing mob programming, refactoring is going to cause a conflict. That's just a fact of life. And there are ways to mitigate that, but even using, I actually asked Sam Newman, the author of the monolith to microservices book, about how he would mitigate this big merge conflict there was going to be, or this double maintenance there was going to be. He has to have one of them, right? And he agreed with me. There's no way to actually avoid it completely. You either have it in your version control, which is not good, or you can do like abstraction by branching. No, what's it called? Branch by abstraction, where you do basically again a strategy pattern where you have one part called the old code, and then you can toggle it over to call the new code that is refactored and nice. But that means you have to maintain two versions of all the same functionality for the duration while they're both being developed on. So there are like the merge conflicts things are definitely a real pain of refactoring, and they're a necessary pain, unfortunately. That's also why you have to do it before you put your code into master, because then there's going to be no conflict yet. Then to go back to your actual question, which was about tooling, I recommend that that I always put on pre-commit hooks for the putting the semicolons and replacing spaces or tabs or whatever, picking whatever standard fits the team, and then do it before the commit happens on each of the developers' machines. And then you just, the only thing it saves really is that -- ignore white space on your Git diff. But it's nice.
Yeah.
So we're quickly approaching time. I'm sitting here drinking orange juice. Brad's drinking a beer. The dichotomy here is kind of weird. And I want to be cognizant of everybody else's time. I know Frans and I actually need to start our days at some point. So Christian, if listeners want to find you, they want to find a copy of the book, they have questions, they want to reach out and maybe get more engaged in some of the things you're offering around these sort of practices, where do they go?
So if they're companies, they can, of course, contact the company I work for. We do consulting and we do training. And I love to go out to teams and talk about technical agile coaching and stuff. I also have a Twitter. I have a GitHub. I have a stream on Twitch. And I have a blog. And then I have my book on Manning's webpage that also has a forum. And people can reach out to me on any or all of these platforms. And I appreciate it very much. That's how the book goes from good to great, is through people contributing, both the people I work with at Manning and my reviewers and everyone who reaches out. So I love to engage with people there, and it just depends what sort of what sort of lead time you want on that interaction, because my stream is obviously the quickest answers, and then you just go down the list.
Awesome. Well, Christian, on behalf of Frans, Brad, and myself, I want to thank you for taking your time today to speak with us. On behalf of Christian, Frans, Brad, and myself, I want to thank all of our listeners for once again tuning in and listening. If you like what you've heard, you can please give us a review, a rating on Stitcher or Spotify. I know podcasts are moving on to Amazon now, so your podcasting platform of choice, please leave us a little bit of feedback. If this is your first time tuning in, why don't subscribe? Like I said earlier, we have a very, very vibrant Discord community right now. There was a long conversation going yesterday about leadership and frameworks, and we went all over the place. But there is a technical practices thread as well to what Christian was speaking of. So if you're interested, please hop on our Discord server and check us out. And lastly, our shows are always going to be free, but we do appreciate any listener support to defray hosting or production costs. We do have a Patreon out there, which I will throw in the show notes. If you sign up, we appreciate it, and you might get a surprise in the mail. So on behalf of everyone here and on behalf of myself, I want to thank you all. And until next time, this is the Agile Uprising Podcast signing out.
Thank you, guys.
Wash your hands.